Hello everybody, it's Crazy Logics 007 on YouTube, Crazy Logics in the forum, and everybody else just calls me Damon. Today we got a Phoenix Gold Z10001. It's come in, it's in Protect. I have noticed that it's got some melted plastic here, so it's got up against something hot at one point in time. The connectors look like they've been kind of rubbed a little raw connecting, but it's got all its 40 amp fuses in it, and that's what it's supposed to have, so that's a good sign. So right off the get-go, we put our meter in continuity mode. Our diode check, it's continuity and diode check, so you can get a beep here. And let's see if I can get the glare off of my screen. Prop it up here. Oh, I just glared it even worse. Need to be. If I turn this off, does that kill the glare? That killed the glare good enough. All right. So you got your probes hooked up correctly. So take your black and put it on the ground, and the red on the positive, and you're watching the charge. You want this to go all the way up like it had no continuity. So it's going to go all the way up on my meter anyway to a 1. And bammy, it did. So that's just like it's set and open. And what that's doing is charging the capacitors. Now, I happen to know the feller pretty good that brought this to me. He does some car stereo stuff on the side, and he gets some trades and some pickups and all that stuff. And so I trust that it's going into Protect. So I'm not going to try to power it up now. But what that did is it tested the power supply circuit, and it charged these caps. So the power comes in here, it charged up these caps. If there's anything wrong with the power supply FETs, and we have 1, 2, 3, 4, 5, 6 here running into this transformer. Looks like we got 2 sets of diodes. So we got 3 in a bank and 3 in a bank is what we should have. But if there's anything wrong with the gates or with these FETs or these caps or these diodes right here, these are reverse protection diodes, that your meter won't charge all the way up. It'll stop, or it'll read, if something's really bad, it'll read a dead short. But you can do that to make sure that, okay, the power supply is pretty good. Then you can come in here, and so this is a Class D amp. So that's the power supply section. It's always going to have the big fun toroid that's got the little windings on it also. Might have multiples if it's a big amp. Some power supply filtering, which has got a couple different brand caps in here. I don't know if they ran out halfway through manufacturing or what. But you kind of need to identify the FETs that are feeding this, and they're going to be labeled Q. So I got Q23, 23, 23, Q23, 4, Q24, Q24. Now, it's actually Q24, Q24A, and Q24B, Q23, Q23A, Q23B. So on this board, that nice labeling, let's see if I can zoom in there and get you a picture of that. So we can get a focus. A little bit more. See how that's Q24, 24A, 24B, then it goes Q23, 23A, and 23B. That's really nice that they label the board that way, because it confirms that that's a bank. These 3 over here are a bank, and these 3 over here are a bank, and that's going to be your kind of your push-pull going through this transformer. So this bank's going to switch on going through part of the half of the transformer. It'll switch off. This bank will switch on, and then that's going to generate the voltage. It's going to go through your diodes here. They've apparently, because these are D72A and D72, so that's a pair of the same, and they've actually got, let's zoom back in. I got to get better at my camera here. You'll have to pardon my little burps here. I've had some root beer, and so they've done D71, D71A, and see, they even got the positive and the negative there. So these rectifiers, gotta zoom back out here. When the power supply goes, it's going to feed into each of the outer legs on this side and each of the outer legs on that side, and it's going to give you your positive half of the rail, rectify it. It'll block one side of the wave that you're getting, and it'll let the other side pass. And it's going to give you positive through those, so you can test for positive voltage on the middle legs and negative there. And then these are the rail caps, so you're getting basically positive and negative and the rail caps to help smooth it, and that gives you your positive and negative rail to go over here to your outputs. Now your outputs are going to run, they're going to run through these shunts, and these are current sense shunts, and then go out through this filtering coil, and then it looks like it's got some filtering caps here. I'm going to make sure those ain't swollen at all. They all look kind of the same. Not, what brand are these? Some off-brand, but that'll go out to your outputs here, and so this does the filtering out to your outputs. We've got some control chips over here. These are probably for the power supply, and yeah, that's a TL494. This little comparator or op-amp comparator will be for the different shutdowns. And then over here, looks like, what we got? What are those? Let me grab my handy dandy thing so I can read the numbers real quick. Yep, we got an IR2184S and a TL072. So this is going to generate a triangle waves and maybe combine the audio with it. And then this little chip right here is going to control these big FETs here. So we've tested in. We can go through and test each power supply FET. I'm going to spin this around and kind of tilt it just so you can see. We can put our meter on continuity, and you just check leg to leg on each one of these. And you're looking to hear a short. And you go through all these, and you might hear it beep for a second, but then it'll go away. That's fine. That means it charged up some of the caps. As long as it goes away, it's fine. Now on the rectifiers, so on this style, the outer two legs are the same point basically. They're actually they're both the rectifiers. Either the cathodes or the anodes will both be sticking out, and then they'll have either a common cathode or common ground. So normally the way they wire these up, the outer two legs will always be a short, so we can just go through it and we'll make sure that they all short together. If you don't get that kind of beep, that means you may have a trace burned up. But what we want to do is check from the outer legs to the middle, and you might hear it beep for a second, and that's it charging these rail caps. Oh, that's good. As long as the beep goes away, you know that you're just charging up the rail caps. And there's not a dead short there. So let's go over here. And we can check the FETs. So I'm just putting my probes on the gate, then the drain, then I go over to the gate and source, and then I go drain and source. We're just checking for shorts. We're not checking for leakage necessarily, because leakage can be hard to detect with a multimeter. But we're just looking for dead shorts, which is normally a sign like the outputs have blown. That will put in protect. If its protection circuit's good enough, when the outputs blow, it'll go into protect, and it'll save the power supply. This one, no shorts. We checked, the input here. That seems good. No shorts on the output. So now I'm going to want to look at the board and just see if anything jumps out at me. So I have to get my old man specs on. Like I said, I'm inspecting the top of the caps. These look a little weird, but they all look consistently weird. So normally you'll have one go worse than one that's not. It's a little weird that these are been different than those. Are they the same rating? Has this one been fixed before? 25 volt, 220 or 2200 microfarad. 2200 microfarad. So they're just different manufacturers. They may have changed in the middle of manufacturing to this brand or from this to this brand or something, and just finished up. Ain't gonna hurt it. It's just filtering for the power in. So I do see something. I'm going to continue to look here, but I see right over here. Let's see if I'm blinding y'all. Sorry about that. Let's see if we can zoom in. Get a screwdriver out of the way here. There we go. Get something to point with. Right there, I see a burnt resistor. And so that burnt resistor is over here by a couple of diodes, some smoothing caps, these resistors here, and these right here look like they should be probably the plus and minus 15 volts for, let me back out here again, probably going to be the regulators for the plus and minus 15 volts for this preamp section. So I can look at that, and if there's a couple different things they can be, but let's see what this one is. It says it is a KIA, both of them are a 7815 and a 7915. So 7815's right here, and the 79's right there. So that's the plus 15 volt regulator, and the 7915 is the minus 15 volt regulator. And so we've got a burnt out resistor over here. So that resistor, those resistors are going to be the same. They are brown, black, black. Get my fat head in here. Hang on. And some light. Yeah, brown, black, black. So brown, black, black. If you look on your resistor chart, and somewhere around here, I got a little resistor spinner. But that's going to be a 10 ohm. And actually, we can just grab the, that's why a resistor chart's handy to have on the wall. So, you know, like put up on the wall, up on your workbench somewhere. Also, along with the pie chart that's Ohm's law with power, current, resistance, and voltage. So you have all those formulas handy. So we are going to go on resistance here. And I'm just going to check this one that's not burnt. And sure enough, comes up 10 ohm. So we've got a burnt 10 ohm there. So it worries me a little bit that this regulator may be bad. And you know, when something like this burns up, there's too much current. I'm sure it's the that's either feeding power. We're going to have to trace it out here a little bit, but it's going to be coming off these little windings, and they're going to go to these rectifiers to help rectify the plus and minus voltage there, just off these single turns. And it's either these resistors are either going to be leading in, which is to help, you know, smooth along with the capacitors, or they're going to be leading out and providing power. I'll have to double check. I'm not, you know, I'm not an expert. I'm a goober, remember. So I have to check things like that. I can't just automatically go, oh yeah, I've seen so many of these amps, I'm just that good, you know. Not me, not this guy. I always have to check those things. So anyway, it may mean this positive regulator is bad, and something had to cause this, so it's probably on the plus and minus 15 volt rail. So one of these opt amps may be bad. And what the opt amps here do is when your RCAs come in, they will bring it in and they're going to condition it, and using variable resistors and stuff and all this extra circuitry controlling these op amps allows all your stuff like your crossovers, your bass boost, your gain, and your subsonic and stuff. So these are all going to each be doing it. Normally it comes in and runs through one, and then that feeds onto the circuit. Sometimes it'll go to the outputs directly. Sometimes it waits and goes through one op amp before it sends it out, so you got a little boost and it kind of helps condition it and make sure it's right. Then it'll come over and it'll probably do they all do a little something different. Some brands do a little different, but you know, I've got gain, we'll just say gain, subsonic, we'll go in the order that these are: bass boost, crossover frequency, and then phase reversal. maybe something like that. And so you know, one of these could be shorted because we've killed this. So we can go over here and look at repairing this, but we need to bring it up on a current limited supply. And that's what I've got right here. This little power supply, this only supplies 3.5 amps. Excuse me. And so this is what I use. If you use something bigger, you need to put a current limiting resistor. I don't have a current limiting resistor at hand to show you, but I've shown it in some of my previous videos. You need like a 2 ohm and then put a 10 amp fuse on it before you feed in power and stuff. The beauty of having the lab style is it'll automatically current limit. So I go to power this up and it may max out my lab supply for a little bit, and a couple amps won't even run off this. Certain style amps won't run off this, and you have to learn that. But it'll limit the power coming in, and if something like this is bad, when I would be testing it, it would help limit the current. But once I repair this over here and see what we got, like replace this resistor and stuff, we can continue to test at low current. It'll be current limited, and if it's shorted, you know, we can let just enough current in here, and we could probably do the isopropyl drip test on these to see if one of these is shorted and stuff. So I'm going to shut up and get to taking this thing apart, and let's see if we can get to fixing it. Try to do a little fast forward or something here for you. Okay, so went ahead and checked real quick. You see me there at the end, seeing how this was done. So power comes up into the rectifiers, gets split between the positive and negative. These are the smoothing caps, and it does go through these resistors to these regulators, and then from the regulators out to the op amps. Now, if we get my big fat head in here, and I still can't see it. I've always got to get a light when I do that. These are our LMO 72s, all of them. So I have those in case we need one. I got a 10 ohm resistor here. So first things first, we know that thing's cooked. So it is right here and here. So let's see if we can zoom in a little. Get the focus a little on the board. Sorry about the little bit of glare. Let me get the fart gun. I love my desoldering gun. Love it, love it, love it. And you can see that part's basically fell out. Take that out. She was, if I get in there, she was a wee bit cooked. So the resistor I have is a 1%. The one that's in there is just a 5%ers, a 5% accuracy, but I've tested real good the one that was still in there. So let's get that there. Fire up the soldering iron and solder this sucker in real quick. We'll get to some solder. There comes up to temperature. Get my blind guy specs. So you always want to get a little solder on your iron tip to help conduct heat, and then you want to come in with the solder from the opposite side, because if everything is up to temp, it'll all flow together real nice. You want it to definitely go up the lead and fill the vias. And there's rosin in the solder. Clip that. Clip that. Throw those in the trash. Isopropyl alcohol, 91% or higher. 99.9 is the best. We'll just clean up any of that flux residue there. And bam. You can hardly tell we were there. Now we have us a nice new resistor here. So now is a good time to power it up, and we're going to have to start checking, see if we got voltage out. Now, let's zoom out a little bit here. So I cheat because I don't remember anything. I'm old and I can't remember nothing, so I got little cheaty cards. So I made an LM card, 7805, 7905 is what I first had, but that's actually the 79XX series or the 78XX series. So these can be 05, 06, 08, 09, 12, 15, 18. The last two digits always mean the voltage. 78 is positive, 79 is negative. Now, looking from the front, power in, ground, power out. On this one, it's ground, in, and out. And that way you know which leg to check on these for power going in and power going out. So I keep my cheat card. Let's make that where you can see that a little better. So I keep my cheat card, and then I got a cheat card for op amps. Almost all op amps used in audio circuits, the TL072, the 833, the 4885 or whatever it is, all kinds of different ones, or 4558, sorry. They all have the same pin out, and so it's going to be V positive up here on pin 8, V negative on pin 4, that's where we're going to be checking, and then you have one side that is the opt amp, and so you'll have the positive in the inverting side, and then its output, and you got the positive and inverting side and its output. And so I just keep cheat sheets, and like this cheat sheet's got the opt amp in this form, and it gives me the V plus and the opt amp outputs and inputs, and then the ground, and whether or not that last pin is used. And so I just have it. You know, you just got to have little things like that. Also on here, I put a FET gate drain source for me to know. LM317s, these are the adjustable voltage regulators. So I got V in, V out, and the adjust. And the adjust is here, and the in is out. In is here, and the out is there. The 317 is adjustable positive regulator. 337 is the negative adjustable regulator. You'll see those a lot in place of the M7815s and stuff, because they'll have set these to a certain thing that they want. So you'll see those a lot in place of those. But I just keep those cheat sheets. I've got cheat sheets for all kinds of stuff. Radio plugs for my pickup truck. Let's see, what else do I got? This is the driver board for a lot of big Korean style amps. Oh, there was an LM 833. I've got this is fuse sizes for power or Rockford Power Series amps and stuff. So cheat sheets for everything, man. It's really good. So anyway, now we need to hook up power. because we've fixed the one obvious burnt thing. We suspect that regulator, which is the 7815, may be bad, or if it's okay, one of these may be pulling it down. So, since we can do some current limited supply stuff, let's see about adding a remote wire. And the power and ground. If I can get my cables out here. You always want to look. This side's ground, and I need to go up a size on my. And so these. Are 10 or 12 gauge, so they're good for 20 to 30 amps on my intermediate power supply. But we're going to go ahead and pull this back around. I will bring this up. We're going to supply power. I've got some extra stuff hooked up here that I need to disconnect. This 1.83 amps is what my test radio right down here is pulling. If I was to unplug it, that would go away. So that is its memory circuit. I've got my foot switch here. We've got our little LED indicator right here. Dirty. Wipe it off. Let's see what happens. We got maximum. Whoa, and we just burnt that up. See that? See all that smoke that come off there? Flat, burnt it straight up. We gotta replace it again. So that tells me something's got to be wrong through here, or we've got too much. So what I'm going to do is I'm actually going to pull this resistor and this resistor out. We're going to power it back up again. We're going to kill the power right now, but we're going to take a measurement here and let's see if I can zoom in. We'll take a measurement right here and right there to see what kind of voltage we're getting rectified before the regulators. So we had smoke. So we get that resistor out and that resistor out. So we know we'll have to replace that one again, so I'm just going to chuck it in the bin right now. We can power back up. Now we're going to want to set our multimeter. We're going to set it at 200 volts. And when you're working on this preamp side, you can use the RCA jack as your ground. We're going to see about powering it up now. We'll stay and protect. I'll try to flash. I've got 18 volts there. And I got 18 volts there. So I'm also going to fire up my oscilloscope. It takes a little while to warm up normally, but I'm going to put it on DC Adjust it out here. I'm going to go ahead and look at this voltage. And so there we are up at 18 volts. And there we are down at the bottom at 18 volts. And it's not got a ton of squigglies. We're going to adjust through the range to make sure it's pretty smooth. So it's smooth. These caps are doing a good job smoothing. It actually goes through the rectifier, through one cap, then through the resistor, and then to the other cap before it goes in here. So with that being said, I'm going to pull this regulator. So we shut off our power. We're also going to where that burnt, clean that up. See how dirty that got? So clean that up and dry it out a little. We're going to go ahead and take this regulator out. Now, without putting it in some other circuit without a load on it, I'm not sure. Those little testers, I do not believe they can test voltage regulators. So first thing we're going to do is give it a, ooh, and it is warm, very warm. So let's put our multimeter to ohms. Nothing reads shorted. I don't think these little testers test them. I know some of them definitely don't, but we'll just see what it says. No undamaged part. Thinks it might be some kind of diode. So that is a 15. Let me see what I got up here. Voltage regulators. Where are they? Kind of changed around stuff, and now I have seemed to have lost my voltage regulators. Ah, there we go. In my drawer of voltage regulators. Gee whiz. So we need a 78. Yep. 7815. 79s. What do we got here? 7815. Yeah. I don't know if I can get it to. There you go. 78 M15. So different brand. It's still going to be the same pinout. We're going to go ahead and fire up the solder gun. We're just going to replace that one. It got really hot. I'm suspect about it. Spread those legs just a little to hold it in place. Somewhere. Our little resistor roll. Did somebody see it? Somebody point it out. Where'd we lose it to? There it is. Found it. And I'll grab one more of the 10 ohms. There we go. Out of my resistor box. So I'm actually going to put this short-legged one in right here. It's easier to get to. And then just tweak the legs out. But the reason being is because that one that's buried down in there will be easier to do with one with long legs. So we got that down in there. We'll pull it tight. Oops. Spread the legs out a little. We're good to go. Alright. Solder up the resistor. Now I'm suspecting that that regulator was bad, but I still think something may have caused it. Those don't normally go bad unless there's something to go bad. That one's coming all apart. All right. You ready to see smoke again? Let's zoom in this time in case there's some good smoke, so you can really catch it. So what we're going to be looking for is if that resistor smokes. We've replaced this regulator. We'll power on up here. I'm just going to touch it. And I just seen a wisp of smoke. I don't know if you've seen it, but I did. So before I burn this thing up, I'm going to check some other stuff. So we kill the power. Now there's a cap here and a cap there, and I think those are smoothing caps after the fact. So I'm just going to double check here to here. Make sure I don't get a reading. Oh, you can't see nothing that I'm talking about. So there's two little caps here. I'm just going to check them in diode mode. Make sure they're not a dead short across it. 0.8. And I get infinite over here maybe. No, I get, yeah, infinite. And over here, I get 0.8. So that makes me awful suspicious of that little cap. Super easy to take that cap off and measure it again. Let me, while the soldering iron's heating back up, let me show you what I mean. Let me get down here and get a little focus. So, I believe these are smoothing caps. Ooh, and there's the soldering iron ready. I believe, let me get a pointer here, these are smoothing caps on the outside there, and that one's reading super low across it. Still doesn't mean anything, still could be shorts in here somewhere. What we're going to do, we're going to add a little bit of solder each end of that cap. And I'm just going to kind of go back and forth on each side. And she'll come off there. Little stuff like that, you can do that kind of stuff. Now, we'll let it cool for a second. But we can go in here and test these pads again. We're getting a really low reading. Now we're getting real high reading. Alright. Well, I just tried to flip it away. Seems like it's charging. Okay, I am holding the leads on there. It should be going up to 0, and I just keep slipping off. So the answer to that problem is a little blue tack. If you don't know what Loctite blue tack is, it's just some tacky little silly putty type stuff that you can use to hold stuff. It's great for 3D printing because you can add it up underneath for supports, all kinds of things. So let's zoom out just a little. So I've got the cap in blue tack now. Now I can get a solid reading on there. 27. Should not be 27. Watch what happens to the meter when we go across this one. It's going to go at 637. So, and if I was to pull that cap, which is what we're going to do next, because we need to know what value it is, that cap that's good should actually fully charge and go up to a full reading, readable reading. So now that I've got some fresh solder on each side of that cap, I'll give a little on the face of this so I can run it back and forth. Until it pops off there. I got one end off. Alright. So let's slide this out of the way. It's hot. Let's see if I can get the blue tack in there in the camera shot. So we need a little bit of separation here. This is the bad one on the left, good one on the right, or what should be good. Still in diode mode. Bad one reads 30 across. Good one jumps all the way up to nothing. So we have a bad cap causing a major short. Here's our good one. We're going to set it over here. Our bad one we're going to set down here. So the last thing you want to do is match up your meter readings across where those filter caps were. That charges all the way up to nothing. Same with that one. We'll do it the other way on the probes just to see. There might be a diode reading. Nope. And if I can get out of the way. So I got a diode reading here. And I get a diode reading that way. If I go the other way, nothing. Nothing. Charges all the way up. So I'm pretty confident that was a bad cap causing a short, burning up As a matter of fact, this might be okay, but it's been so abused, in the trash it goes. I'm not going to keep an abused one. As a matter of fact, we may change that resistor out again. Let me measure it here, because I did see a wisp of smoke. It still shows 10 ohms, so we'll see if it gets hot. So now, what we need is our little tester. Anytime you test a capacitor, you need to short it and discharge it. One of these, so I'm just shorting it with this pair of tweezers. And I need to find some test leads or some test wires. Give me a minute, I'll be right back to find my little test probes to put in here so we can test this. Okay, so we're going to put on ohms. The meter, I've got my little test leads out here. This should be the bad capacitor. We're going to test it in ohms. It's testing at 26 ohms. We're going to test the good capacitor. It should read infinite because it's a capacitor in ohms. So we'll put the good one back up here. Get our little test leads. This is where the blue tack is nice. Anytime you test a capacitor, short it out. I've got it plugged into 1 and 3. Push against that and get the button. That comes up as a diode. You see that? Comes up as a diode. That is not a diode. So let's put the bad one way up here. Let's bring the good one down. We're going to short it. We're going to get our leads, and we're going to take a couple of times a reading on this because we're trying to determine what size it is. And there is what it should come up as. A capacitor. It says 10.88, or is that 00? 10.88 microfarads with a voltage loss of 0.9% and ESR of 0. So let's test it one more time. I'm short it out. Really important on big electrolytic style capacitors to short it out, because these testers rely on charging the cap to know what the voltage is and stuff, and it can be dangerous high voltage back into it. So it comes up 10.95 microfarad on the good one. So I'm just going to take this bad one and straight throw it in the trash. Put my blue tacks together. So we're somewhere around 11 microfarad. We put the tester away, and now my hunt begins in all my parts for 11 microfarad. Let's do something fun. Let's go to clock. Can you see that? You cannot see that. Let me turn off the overhead light there. Still can't see it. All right, right there. I'm going to stop the video. Let me get ready to stop. Right after I get this started, we'll see how long it takes me to find a 10 to 11-ish microfarad cap, or two that will make a match if I got something a little more. Since that's a smoothing cap, we can go a little bigger, I think. But let's see how long it takes me to find it in this mess. So here we go. It has been over 25 minutes later. Yeehaw. So that's not cool. Did not find one. Here's that little sucker. I don't have any. I can order some. I do have that will fit on those pads. I got some 10 microfarad little electrolytics. I was hoping they were 25 volt, but they are 16 volts, so they're going to be right up to their voltage limit. I'm going to leave that on. I'm going to go ahead and clean these pads up. and switch tips on my soldering iron. But I want to at least get this thing up and functional. I might be able to find one on a donor board, but it's going to take some looking. That's what I was looking and didn't find anything yet. And so I was like, screw it. I know I can use those at least temporarily to get us further along in the testing, see if there's something else here drawing it down. So now we've cleaned up those pads. Switch my tips. Smaller tip. Get that heated up. So what we need to do is put our meter. We got our meter here in continuity mode. Yep. So 2 of these pads are going to be connected if these are smoothing capacitors. And those 2 seem to be. And then this one, if we look at our cheat sheet, the output for the positive should be the 3rd leg. So we're going to look at that. We want to see if it, yes sir, and it is not connected to any of the other pads. It is connected to that pad. These 2 middle pads are connected together, and I can see they all form a ground plane there. And then we need the output, which is going to be this outer leg for the negative. If that is that pad right there, it is, beep. So that's going to be the output on the negative. So these caps are polarized, unlike the little will be ceramic caps, and so the little black piece represents the negative. So this has got basically 3 pads. Those 2 pads, this pad, you can't see that. Let's zoom in here and make sure I explain this. So this pad is connected to the positive output rectifier. This pad way over here is connected to the negative rectifier. These 2 pads are connected together, so they're the middle. So there's 0 volts basically. So this is going to be positive 15, 0, 0, negative 15. So this is the way the negative needs to go over here, and on the 0 volts, if this is positive and this is 0 volts, that's going to be the negative side. So we have to make sure we install these correctly. So they're going to set in there just like this. Just make sure I can get some light or some focus around here. Let's see if we can get a little closer. Maybe a little further out. So you can see how the black negative indicator is on that side on each one. That's how we're going to solder that in. Ooh, good old zoomy. Alright. So I'm going to get those out of the way. I'm going to put the smallest touch of solder on each pad. Just enough. Go along there. And if I can find my flux, where did my flux go? It's not its normal place. There it is. A little bit of flux on each pad. That way we can solder these in. Once again, get a little bit of solder on here. that end. So we can get this end. We'll come back in and make sure it's seated all the way down. A little bit more solder on there. Looks good. Get this other one in. Turn the board where you're comfortable soldering. More solder. Barely got that one in. Back and resolder this front edge. Get that cap down. I think that's got both of them. Electrolytic caps, I like to put as little as heat as possible into that cap, especially small caps like that. I hand solder a bunch of these caps when I build my PIM modules. See that? Those two caps in the middle. I hand solder all those so they don't go through the reflow oven and get the cap too hot, which is what causes them to eventually get crappy and leak. Electrolytics just do not like lots of heat. And I may change this resistor out, but we're going to give it a test. So we're all zoomed out. Got power up there. You give it a blip. Another little blip. Another little blip. Hey, looky there. We got a bright light and I don't see any smoke. Let's go to voltage. We can remember we can use the outer RCA shield as our ground. And on this cap here we should see we got 15.2 volts. And we got negative 14.9. I'd say this thing will probably work. So let's fire up the radio. I need to get my in piece and see. These are the inputs. Phase needs to be turned all the way down. Crossover frequency we're going to set. Uh-oh, there's part of the problem. See that? She just spins. Somebody broke that, so that didn't help. So we cannot test yet. This is the bass boost. We're going to turn it off. This is the subsonic. We're going to turn it all the way down. And the gain, I'm going to turn it all the way down. So what we have here is the crossover Sheeby Scoot. So no test for now. Now we got to look at this thing. Dad burn it. But at least we fixed the dog fur on there. At least we fixed one thing already. So where these can get tricky. Bend these legs up a little. Give me a fighting chance of getting them out of there. Fart good for the win. And then out it pops. B50K. I'm not going to put the timer on this tie when I go looking for parts. I'll be right back. And we're back, and it's like a week later. So I still got the original little cap there that was good, but I ordered more. And I'm not going to put this cap in. I'm actually going to just check it because I'm worried that cap is available to buy at 16 volt, and this is at 15 volt, and we had soldered in, and I've already removed them. Zoom in here. Remember we did some testing. I soldered in those two electrolytic caps. Well, now I've removed them. I've also removed the resistor that had got a little smoke to it. I wasn't going to trust it even though it was testing good. And then I didn't have a donor board or any parts to replace that pot. I had to order one, and the only one I could get is a little bit longer on the shaft, so it's going to stick out the hole ever so slightly. There's nothing I can do about it, because otherwise it was going to be wait months, maybe not get it at all. I was having terrible luck finding it, and so I said screw it. Sticking out just a little bit past there, you know, the RCAs already stick out past that far, so it's not like it's going to be a showstopper. It's better than it not working at all. And sometimes you just do what you got to do to get it fixed. So we will solder that in. And I already put a little black paint on the end of it to help. And so at least we'll get this one done, back operational and back playing. Hopefully. I say that, boy, knock on wood, I've had just god awful luck. Parts are hard to come by right now, and everything it seems like needs to be ordered, and just all kinds of craziness. It's not the repair industry or the car industry or anything else that's just experiencing shortages. It's every industry. So whether or not you can't buy a new amp, or you can't buy parts to fix your favorite amp, it's been a little rough. I know a lot of guys are sharing parts between techs, and because suppliers in the US don't have any parts, they're all having to make some, oh, you guys can't see any of this. Sorry about that. There, I've done all that soldering. Look at all that soldering I did, just babbling, and you couldn't see a thing. And so it's a problem industry-wide for every industry. And so if you can't get something bought new or fixed and somebody looks at you and says sorry, I don't know. Like I said, there's a lot of techs that are sharing parts, sharing big massive quantity orders from suppliers so they can try to get them in faster than what the U.S. suppliers are, because they just order it and don't care. And so some things are stocked in reputable suppliers overseas, but they have a huge minimum quantity order. And sometimes the shipping can be outrageous. So I know a few guys have teamed up and split the costs. And everybody's trying to help everybody out, which is really cool and encouraging, because it's really cool to see the repair community come together and help each other out and stuff whenever everything's going to crap. Instead of, somebody can always be a butt and say, oh no, I'm going to hoard my stash that I happen to get 200 of this chip that's no longer available for till Christmas. But no, those guys are, like, hey, yeah, I'll send you a few so you can finish those few amps. Just, I ain't sending you, nobody's sending each other enough to keep taking in a whole bunch of that certain kind of amp or whatever. They're just saying, finish what you got, get them repaired, so you can let all your new customers know that, sorry, this amp can't be fixed until a certain date the parts come in. That way, at least customers that have been waiting a while can get their stuff done, which is really cool. Kudos to everybody out in the repair community, whether it's amplifiers, game consoles, laptops, MacBooks, iPad, phones, all that stuff. And if you're one of those crap places that isn't sharing, then shame on you. You're giving the rest of the repair industry a bad name. That was my holier than thou rant. I'm not really holier than thou, but so on these caps, I was worried that because you can buy this cap in different voltages ratings, and I was worried that maybe the original factory ones were 16 volt and they were just running them right up at their limit. Maybe that's why that one died. That happens. They sometimes they get a little tight with the specs, and it can cause bad problems. So what I did is I ordered the correct cap, 10 microfarad, but I ordered it 25 volt. So plenty of extra little headroom there. You can go up to double, so I could have got 50 volt, but then they were going to get kind of odd sized, and they weren't going to fit between the pads just quite right. Well, they might have. I thought the pads were closer together than this. I was looking at it. When I was looking at it, it still had the other caps in it. So it seemed a little goofy to me, but there's a chance that it might have been okay. So I'm going to see if I can get these to solder down without trying to get hot air in all around all this plastic. Otherwise, I'm going to have to use Captain Tape to protect it all. So hopefully I can get them to hold down. It'd be worth a darn. A little extra solder on there. There, I think that's held in place. And once one side's held in place, it makes the other side easier to solder. Trying not to touch everything with my soldering iron. This one takes a wee bit more heat on this side because it is the ground plane. Boost me my iron up a little there. Can't tell without sticking my fat head in the way. Hang on, guys. Sorry. Oh, that does not look good. Add the tiniest splash. A little flux just to make that go a little nicer. Except this side's going to be a little harder because it's actually a big ground plane. That looks better. Okay. So I'm going to spin this around. Ooh. There we go. So I can get at it from here. This side, once again, is not the ground plane. Just want to get it tacked there. I'm going to have to make that a little better, but I need a little more solder. Get a slid in the spot here. It's hard to do and try to not be in the camera at the same time. There we go. Now we can do the other side, which is the ground plane again. I'm just going to go ahead. It just helps with a little flux on that. Once the ground plane side's done, I'll touch up the other two again real quick. We'll go ahead and add solder to the soldering iron tip. Looks pretty good. Touch that one off there. Those look good. Alright, so we got the right caps in. Replace the resistor. We now have a functional crossover. So I'm going to set that right in the middle. And I think we can now test it like we were going to test last time. So I need to spin this over and see about getting some wires to hook up. Oh, so yeah, I kind of wanted to replace those caps with the right thing that it had, but I wanted to make sure the voltage was high enough because the electrolytics that I was sticking in there, they were 16 volt also, so I just didn't like being that close. You know, it already had a failure there, obviously, and so let's just go ahead and put a little bit more safety margin. They may have been 25 volt ones that were there. Maybe they puked. Maybe there's a spike or a surge or something, or maybe it was just unfortunate coincidence. Move this back in a little more, but run this one back out. Okay, so where were we? This amp had a problem in here, so we may still have problems in these, but we're willing to test it now. Let's see if I can bring up that one. And I'm going to bring up the power supply. And I'm going to pulse it. Just a few times to get these caps charged up. And bam, it turned blue. So far so good. I don't see any smoke from in here. That's a good sign. So we should be able to look at this. We should be able to power it up. And if I can get the timing to... There we go. There's the trigger. There is the low side drive. Same on both those. Yep. So there, and it should be nothing on here because we're not making any waveforms on the. Oh, there's the high side. All right. So it seems to be working. Let's see if we can get audio through it. We need to check and make sure these are not warming up. They were not. Those aren't too hot, and the two diodes aren't too hot. So that is good. Let us see. Left and right. We got output. We got the input is right here. So, oh, my wife's putting the garage door down. Cat was trying to get out, and it scared the cat back in. So we got the garage door open because it's hot summer here. All right. So let's fire this up. We're going to swing the scope into AC. Set my radio to play a little 60 hertz sine wave. Alright, this came on. Here's the speaker terminals, one of them. Ooh, it's awfully wild and crazy. It may not be good. I can't remember when we were doing this. Let's see. Nothing hot there. All seems okay. That was definitely 60 hertz, but we need to see what our knobs are here before I call it good, bad, or ugly. And that is the gain. I need a little flat blade. There we go. Let's do that. Okay. That does not look good. That does not look like 60 hertz. Oh, there's 60 hertz. It still is a really fat. I don't know if that's going to sound good or not. That is not what a good Class D should look like. I'm going to turn the volume down. Well, sounds like a sound wave. Oh, there we go. That's starting to look better. Let me change that. That looks a lot better. Now we're actually putting out volume. It's a little thick on my scope, which is okay. That's a product of the filtering, but that was just because our volume was so low. So that looks good. Okay. We were just so low in level that it was I guess the filtering doesn't do as good a job then. So let's turn this down a little. You can hear it. It's playing, man. Boom, ba doom, ba doom. Probably turn across a little more music through. All right. So I'm gonna shut the amp off. I will clean it up, put it back in the case, and I will load test this to make sure nothing else is wrong. But remember, we didn't have to fix anything there. It was all this audio style on them. Can't imagine when this got broke, whoever was turning it, I can't imagine them that somehow causing that either. I don't know. You know, it's not mine. So I can not imagine lots of things. I'm not perfect at troubleshooting. If you are good at troubleshooting, you at the camera, that people right there watching, yeah, if you are a smart repair tech and have seen that or whatever, always leave it in the comments below. Man, I'm always trying to learn. So help a guy out, help a goober out. Let's see, is this thermal paste is still a little bit wet, so that is good. And we'll refresh it a little here with just a nice little rub. But yeah, man, I take all comments, criticisms. I don't care. I don't know everything. That's for certain, obviously. And I'm always willing to learn. And sometimes I get things half right. But maybe I don't explain it right, or maybe I know what I'm talking about and I just can't explain it. That's happened to me a lot. So oh, my words are failing me. It's getting late, guys. So like I said, leave down in the comments if you know something more than me or can help me out. I'm just doing this to try to help people out and spread repair. You know, I try to recommend in my comments good repair shops, which most are super busy right now. So it doesn't matter what, even if it's not a repair shop, if it's a shop of any kind that's doing work every day, if they're making speaker boxes, if they're doing installs, they're all super busy, all under a lot of pressure, backlogged, having a hard time finding parts, all that stuff. So, you know, be kind. That will probably get your stuff in a little faster compared to the person that's being a Karen. So somewhere's the heatsink. There it is. Oh, I gotta work on these. These are all goofy a little bit. I'll clean them up. Like I said, I'm gonna slap it all back together, and this one will be up and running. Maybe I'll pop in right at the end before the end of the video when I show you it all finished up here. But I'll stop blathering. Be nice to everybody. Help everybody out. You know, everything's a pain in the butt right now, and we all just want it to be a little easier, and it will get there. It just takes time. And I hope you repaired the video. Hope you learned a little something about the plus or minus voltage for the op-amp drive and stuff. I've got a couple of videos where that's been part of the repairs and stuff. So a whole bunch of videos recorded, partly recorded stuff like this where needed one part, you know, or a couple parts, and I've been waiting. Then I finally get them in, and I've got a bunch of other stuff backlogged, or I fix, like this one we got lucky. I'll fix this, and then I'll discover something else needs it, and so I got tons of video. But I also have a project midlife crisis. You're going to see a video of that coming out, little thing for me and my wife, and so Fun. And a whole bunch of other stuff. I got a old school SPL challenge video. Like Project Midlife Crisis, my SPL complete, the old school challenge one. And I'll stop by there. Man, guys, thanks for watching. I totally appreciate it. And I still got a 1,000 subscriber. Thank you. I'm about at 1,200 or 1,150 or something, which is crazy. But gotta talk through that and tell you the plans for the channel, kind of thing. So look for those videos. I'm trying to get them done. Just had lots to do. Everybody has right now. Had a lot of things that came up that made it really hard to get some things done that eats into your time. So just keep going. We'll keep working through it, man. And come winter, there'll be a lot more videos and live streams, just because it'll be winter and you're not out running around or doing stuff as much on the weekends. With cold, crappy weather, you want to stay in. So always look forward to winter for that purpose. I don't like winter. I like summer and going out and running and doing fun stuff. So stay safe, and thanks for watching. See you next time. Hey guys, here we are. I'm doing a final test now. It's back together and make sure it goes right before I throw it on the load. There we go. She is playing. See, we no longer have a clip light, or a protect light, I mean. You can see the crossover sticks out a little bit, but actually when you look at it from the top, it can't even stick out, so it doesn't even stick out as far as this. So that ended up being really good. So we got this thing fixed up, and then we'll put the bottom plate back on, but she's all back together. Ready to go. Yes, it's always upside down in the camera shot. You know, I don't have enough cable to flip the whole thing around. I'll fix that one of these days. So, alrighty. Time to clean it up a bit. We're going to put this cover on. But, yep. Bubble bam. Thanks for watching.